Hello, everybody. I'm going to be covering 2015 BC Calculus FRQ number 5. So if you consider the function f of x equals 1 over x squared minus kx, k is a non-zero constant. The derivative of f is given by this. They actually give you that. So if they're telling you, first of all, if k equals 3, then this is your f of x. Write an equation for the line tangent to the graph. Well, that's pretty simple if the x-coordinate is 4. You need a point and you need a slope anytime you do a tangent line. So very common question. So to get the point, you just substitute 4 into regular f, and you end up with 1/4. And then to get the slope, you just plug in 4 into the derivative, which is already given to you. You just have to substitute in those k's that are given, k equals 3. So instead of k minus 2x, it's 3 minus 2x. And you know that the x-coordinate is 4. So you end up with negative 5/16 as a slope. So the slope is worth 1 point, and then the tangent line equation is worth the other point. So the best way to do this is to basically use point slope form. So y equals m times x minus x1, and then that's where the 4 comes from. And then instead of doing y minus y1, we'll just bring over the y1 to the other side. And the equation above where I'm writing here basically is the equation of the tangent line. Now, I certainly hope that you're not going to end up simplifying this. If you can verify that it's the same as the one given here, but by all means, I would highly recommend you not simplifying that equation. So 2 points for the first part, part A. Part B, so now they're changing the k to 4. Determine whether f has a relative maximum, minimum, or neither. Well, there's 2 ways to do this. The first derivative test, to check when the derivative goes from positive to negative, or negative to positive, or neither. And the second derivative test, now I don't have the second derivative, so it's probably not convenient to do the second derivative test and check for concavity. So the best way to do this is to just, first of all, check to determine whether f is a maximum, minimum, or neither. So you use f prime, and then you substitute your 2 in for x. So here you have an x, and then here you replace it with a 2. And then here you have x's also, and here you replace those with 2. And you do end up to get 0 for your derivative. So since you do get 0, you know that it is either a maximum, like this picture here, a minimum, or it could be one of these neithers. So since you already have the first derivative, it's easy to double check. There is no x and y here, which would maybe indicate a second derivative test. It's just x's. So let's check to the left of 2. So that's a 1. And let's check to the right of 2. And then I'll just check a 3. Since the denominator is always squared, you're going to have positives here in the denominator for both parts. But if you substitute in a 1 there, you get 4 minus 2, so that's positive. If you substitute a 3 in there, you get 4 minus 6, so that's a negative. So positive to negative changes from increasing to decreasing. Therefore, you have a maximum. So answer with justification. The justification probably is this purple underlined sentence. Since the derivative changes from positive to negative x equals 2, you have a maximum. So as long as you kind of explain that, if you just did it with a chart, you will not get the point for the justification. Charts are not acceptable. You need to summarize charts via words. So as long as you considered the derivative at 2, and then your answer is fully a maximum, because the derivative changes positive and negative. Part C, find the value of k for which f has a critical point. So to have a critical point, we want to check to make sure that the derivative equals 0. So the derivative, plugging in negative 5 here for all my x's, there in those spots. This is what you end up with. So you end up with k plus 10 at the top. And on the bottom, you have 25 here. And then you have 25 here, sorry. And then you have negative 5k. It really doesn't make any difference as long as you end up with a 0 on the numerator to get a critical point. So basically, you're just kind of checking to see when this numerator equals 0. So the numerator will be equal to 0. Since this is k plus 10, it's going to happen at k equals negative 10. All you really need is the answer for this problem. So all this work can be done in your head or real quickly. If k equals negative 5 would also be an answer if it was defined in the original function, because you could also have a 0 on the bottom, and set the bottom equal to 0. But since it's a non-zero constant, you just ignore this one here. So hopefully you just got the one answer of k equals negative 10. Part D. Now part D is a little bit trickier here. So for part D, the question is let k equals 6 so that f of x equals this. Find the partial fraction decomposition for f. So, and then integrate. So basically, partial fraction decomposition means once you substitute in that 6 that they ask you for, your job is then to, factor the denominator. So you factor the denominator, your two factors here, and then you do your a and your b above each one, and you basically set it equal to the original. Here's the original. And then you clear your denominator. So clearing your denominators, you're going to be multiplying through by x times x minus 6. So this a already has the x, so it gets the x minus 6. The b doesn't have the x, it just has the x minus 6, so the x goes with the b, and then since it equals the 1, it equals the 1. So now, by using the heat aside method, you substitute in 0. By putting a 0 into the x right there will then give you this b term is wiped out. So you get a equals negative 1/6. And then if you plug in 6, that wipes out the a term, and then you just got bx equals 1. You divide by 6, you get 1/6. Going back to this part in the problem, you'll then put negative 1/6 and positive 1/6 back in for your a and b, and you're basically going to be integrating each one of these separately. Now, when I do that, I personally like to pull the negative 1/6 in front, so this is just basically 1 over x, and the antiderivative of 1 over x is ln of x. Bring the 1/6 in front, so the antiderivative of this 1 over x minus 6 is ln of the absolute value of x minus 6. You can stop right here. Let's look at the point evaluations. So partial fraction decomposition is worth 2 points. So hopefully you factored it and set it up like that. You can assign yourself partial credit here. Honestly, I'm not really sure how they would assign partial credit. So if you did get like negative 1/6 and positive 1/6 for your A and B, and you look at that spot there, you did all that right, you obviously get the 2 points. If maybe you make one little sign mistake, I'm guessing I might give you one of the two points, but that's how you get those 2. And then the general antiderivative is either separated, or since it's a negative problem right there in the beginning, you could actually change this to a division by putting the one that's being minus, which is the first one in this case, on the denominator. You by all means do not have to do that. So your general antiderivative could be either one of these. I'm guessing with the 2 points here, if you forgot the plus c, they will probably take off one of the 2, but you got 4 points to be had there for part D. That's it for 2015 question number 5. Thanks for listening today.